Okay, welcome to part 2 of the video. So let's get through this. A woman was exposed to a pathogen during vaccination. That would be the inactive version in a vaccination. A week later she became exposed to the same pathogen. That would be the active or a live version of the pathogen, but she didn't become ill. The reason can be explained using this graph. It shows the concentration of antibodies on the y-axis, the time on the x-axis. So this was when she was exposed to the inactive pathogen. This is when she was exposed to the active pathogen, and it wants you in the question to describe the differences in the first and second time she was exposed to the pathogens. Right, so the first thing that you want to say is more pathogens were created the second time. You see, more antibodies were created the second time compared to the first time. So let's get that down. More antibodies, we could say a greater concentration. Oh, need an N in there. Greater concentration the second time. It's good to give some numbers here as well. So again, using the trusty ruler, we can say that it went to 0.8 units first time and 7.4 units the second time. .4 units the second time, .8 units the first time. Right, so it's good to use the statistics. You'd get 1 mark there, 1 mark there. It's a 3-mark question. As you can see there, I'll just do it all on the same page for ease. A good thing to say here is actually that the rate of production the second time is much quicker, because the exposure to the pathogen comes here and then the antibodies are made straight away, whereas if the exposure to the pathogen is here, it takes a bit longer for the antibodies to be made. So we could say antibodies made faster second time. Okay. Right. It wants to know reasons for the differences that we've mentioned above. So we've kind of mentioned this already, but just to be clear, white blood cells recognize the pathogen, or you could say antigen, on the pathogen, and the antibodies increase in number quickly the second time. Increase in number quickly, more quickly the second time. 1 mark for each. Okay, so really it's just asking you to say the same thing in this question, so it's just good practice for you. The MMR vaccine is just an example of a vaccine. It's there for measles, mumps and rubella. I want you to explain as full as you can how the MMR vaccine protects from these diseases. Okay, so you know, we're using similar knowledge to in the previous question, but you just need to phrase it differently, because obviously it's a slightly different situation, but the theory is the same. So you would say the MMR vaccine contains dead or inactive pathogens MMR vaccine contains 10 inactive pathogens, which allows white blood cells to make antibodies to destroy them. Okay, now that'll get you 2 marks. Dead or inactive pathogens, antibodies can destroy them. Now, the white blood cells can produce these antibodies more quickly when, oh, the light's just gone off. Okay, let's get back to it. The white blood cells can produce these antibodies more quickly when active pathogens enter. Okay, and it can destroy them. Right, 5b, you have to read this passage. Obviously I'm going to let you do that in your own time. I'm not going to read that through now. Let's quickly go through the last couple of answers. So the answer to B part 1 is no, but you don't get any marks for saying this. Right, get marks for giving reasons. So you could say there's few people, only 12. You could say the conclusion is based on gossip from the parents, or hearsay is another word for gossip. From parents. Other reasons are only 8 parents linked autism. Only 8 parents linked autism to MMR, and that would be fine for now. If you get a couple of those points down, the answer for 5b is yes. If you don't get any marks for saying that, you get a mark for saying being paid by parents' lawyers. So, being paid by the parents or the parents' lawyers. So obviously that means they're biased if they're being paid by the people who want a certain outcome. Okay, that's the end of part 2.